Ranak everybody, and today we continue to talk about how the same result can be visualized by the different way depending on the options of visualization. Today we talk not about the option inside of ANSYS Mechanical, but we will talk about the other type of software, about Siemens FEAMAP, and we will open the same result. We will not repeat those calculations. We will import the same result from the ANSYS and take a look to a couple of options and have a look how it can affect and influence to our result. And reasons that we will use for this calculation and for this visualization, the student version of ANSYS. Sorry, not ANSYS, student version of Siemens FEAMAP. I will shut down the QR code of supporting the channel, and let's take how you can obtain as a Siemens FEAMAP student version, who can obtain, what legal purpose can be, and what restrictions and limitations we have. So the Siemens FEAMAP Student Edition can be found with this search query in any sort of search engine, and it's official Siemens site, as you can see, and it's official student version, but it is able not only for student, like ANSYS Student Edition, it also can be used not only for students. So if we open the educational level, we can see self-taught independent study and continuing education professional development. So it's for all people who want to increase their knowledge in those type of software, in finite element analysis, in finite element modeling, and so on. And even if they are not already a student, they can use those type of software because the license can provide it. But there are a couple of restrictions. First of all, you will have the technical restrictions. It's more important for people for some reason. So it's you will have the 25,000 of nodes which you can use for your calculation. I can say 25,000 of elements does present also or not. I know about 25,000 of nodes, but in most cases it's the thing which are connected one to each other. So let's talk about 25,000 nodes and 25,000 of elements. And if your task will be more than this, you need to redo the mesh, delete all these elements, and so on. It's less than in ANSYS, because in ANSYS student version have limitations of 125,000 of nodes and elements, but let's be clear, 20 years ago we created a commercial project which have much less the number of elements and nodes. So for purpose of education, of self-education, it's good enough, and most of tutorial of Siemens FEAMAP official have much smaller task, so it's not a problem. And more important limitation from my point of view, and it's very important, and most people forget about this, the limitation in type of exploitation of this software. You cannot use this software in any kind of commercial purpose. It's only for self-education, for self. So in reasons that we work with the Siemens in our country, with Siemens reseller and with Siemens itself, I can show this result to you, but it's not a material which created in general with educational software for some reason. So you can enter here information about yourself, and if everything okay, if you're from the right countries and so on, you will download and install this software and Siemens FEAM. I use the educational software for this purpose, for showing the possibility. And we have a small issue for the task which I need to show, in reason that the size of the task is more than we have a limitation. It's I do this propose to show how it will work even with those limitations. So we have the number of nodes more than 40k. It's more than 25, as you can see, and number of elements are also more than 25k. It's look like it's not, because 2100, but those elements are not count the contact elements which are also present here. So the general number are less than 25,000. Siemens FEAMAP have ability to import the mesh and the result from other software, and it's a very big advantages of the Siemens FEAMAP software. And it can not only import, it can create a model which can be calculated with a different software. It's also very important as for education, as for commerce use, and it's not about using educational software in commerce use. It's about using commercial license for commerce use. For this task, we need to separate those objects into 4 different tasks, calculate them, save them, and then open separately all these cases. I am the lazy person, sorry. So I do the same thing, but with some changes. I suppress only 2 parts, and then calculate, and then suppress only 2 additional parts and calculate. It gives to me about 30,000, 25 to 30,000 of nodes in every cases. So we have more elements and more nodes, but in most cases it's elements and nodes in contact pair. And in reasons that I didn't want to calculate with Siemens SimCenter Nastran only to show result, it's not very important. But for your case, it's very recommended to leave only the one object and to use it. So when I have a solution, I can right click on the name of it and open solver file directory. And this folder, we can see everything which was created by ANSYS Mechanical and ANSYS Workbench. And those DS file, it's a common file which generated by ANSYS Mechanical, which is input for ANSYS for obtaining calculation. Sorry, not DS file, this file. And this DS is from other video. We will show it later. This file, and this file, it's RTS. It's a result file. So we calculate it. I have, as you can see, the number of files which I enter in FEAmap. You can see when we calculate some of them, and record some of this video. The reason of this I will not explain here, but if you want, you can ask and I explain. So let's return to the Siemens FEAmap and let's use the import file, import, analysis model. We need to select one from the list. You can see the list is very wide, and if you have commercial version and you write answers, this list can be even wider. For now, we need to use the answers. I already have done this, so I open this folder and use the linear mat tetra. So it's tetra with linear material. It's both type of tetra, and as you can see, we have some errors. Some comments was ignored. So now we need to import analysis model, analysis results, sorry, also from the same folder. As the same linmat tetra, and they say that we have absent some elements, so we can't read sum of result, but we continue because everything is fine. So, and we need to repeat this one. We create the new file, and it's very good that we can work with a lot of file if we have enough memory. We import the analysis model. It will be the linmat hexa, so it's hexa with linear material. We import the result file, and during the importing we also obtain some error. Please be careful what results you will import, because you can import a result from other mesh, and you can obtain very interesting type of result. So very important things which we need to do during our analysis in ANSYS. It's to add on mesh numbering, because even we suppress couple of objects, the number will contain the whole model, because it's don't recreate the mesh sometime. So the number can be can start, for example, from 20,000 and end, for example, in 30,000. And it's only 10,000 of nodes and elements, but in reasons that we have numbers which are higher than 25, we can have the problem in FEAmap. So please use the mesh numbering option, which can help you reduce the number of elements and nodes to the minimum. Numbers mean value of numbers, not the number. So as you can see, we have the quadratic element with mid-siders, and we see linear elements with mid-siders, both on hexa and on tetramesh. We can switch off the elements, we can switch all the contact, which we don't need, and the fixation. And in reasons that we already import result, we can show the contour view. So this is one, and this is another. And let's shut down things which we don't need. So as you can see, by default, the FEAmap have different type of rainbow, different type of legend. It starts from the purple color, not from the blue one. And in this reason, those results look not the same for the first view as this one. But it's very important skill to work with different CAE software which use the different type of legend, and in any type of software you can change the legend with the couple of default version, and you can create your own. In ANSYS Mechanical and in FEAmap it's the same, but during the work you will very often work with reports, with PDF, with printed report, and you can't change the color option on printed object on PDF. So you need to have the skill to work with those legend and to understand how one color type and one result with one legend correspond to another. And if you have the skills, you understand that those results are the same qualitative by quality of the picture, by type of the picture, by type of distribution, like ANSYS. The only difference you can see, and it's important, it's the difference of maximum value. Here in FEAmap we have 1490, and in the ANSYS we have 1485. 5 megapascals of difference in almost 50 grams, in almost 50 hundredths. It's not a big difference, it's a very small error, but it's present, it's important. And yet another time, we don't calculate those results with Siemens FEAmap. We import calculated result from ANSYS. We simply visualize this result with Siemens FEAmap. And we have some difference. And even if we create the same type of legend with a strip band, with the same number of colors, with the same colors, the pictures will also have small difference in distributions, in reason of different visualization and different algorithm of calculation stresses and so on. But today I want to talk about some other things. So this is the result which we see, the first and the second. And in most cases it's almost the same. It has some problems here. And this problem can be present in result of problematic import. Check it by yourself. But maybe not. We'll check it later. So, what we want to show today. Let's click on the post options. Here the show control view, and here we can open the post options. And we have two different type of result, the nodal result and the elemental result. When we show the nodal result, the picture not changed, as you can see. And when we show the elemental results, picture for this moment of time did not change. You need to understand only one thing, that FEAmap by default store only elemental result, and nodal result it calculate and show. You can convert the elemental result into nodal result if you work with very big model, and those calculation of nodal results struggle with the time spending, and you need to very often switch from the different results, and this waiting time is it's not good. So you can create those vectors for nodal result, and in those time from this moment FEAmap will switch between the different results with very high speed, very fast. So when we select the nodal options, those options are present, but there are no those options. When we select the element, present those options and those, and it's important. So when we work with the 1 meter stress, and this is 1 meter stress, or when we work with the total deformation, or when we work with the equivalent elastic or plastic strain, we need to understand that result changed from the 0 to some maximum. And it means that the max absolute value are the same as max value. The mean absolute value is the same as mean value. But when we talk about the result of indirection, stress and strain, those results can be different. When we talk about the main, the principal stress and strain, those results also can be different. So let's switch to the max absolute value. And you can see that picture have some changes, but not very. But the result became to 1868.2. So if we return to the ANSYS mechanical and switch to unaveraged result, we can see the same, the 1868.2. But here we can see, even on the best mesh, which is present here, some steps between the colors. So we see non-linear distribution, and even here we see that our elements present with one color because it's only one stress. But here we see a good picture with smoothed color, and it's not about the smoothed band. We will see it later. It's not about. And even here, if we switch to the same result, we also will not have the one color per element. Why it's so? Because we obtain the maximum value from whole number of elements around one node and put those maximum value into this node and then create a linearization between result. So they will be smoothed in any kind of variation. And even if we take here the mean absolute value, we also have the same option. We have some very strange result, but it's also smoothed. In this variant, we take all elements around the node, take the minimum value which we have, and put it here. And can those picture be in result of not imported result, which we see here? Can, but we have some problem. It's the minimum value at any node, at any element. And if we take a look here to the minimum value, it's not the 0. But if we don't import the stress, it must be 0. It must be 0 because it's absent. So must be, not really will be. Please repeat those procedure by yourself with only one object and with compress the number of nodes and elements, and you can check this one and say, will you have the same result or not? So let's return to this one. Let's do the same things here. So we create the mean absolute value and we have something like this, but the picture is almost the same, but the level of result are different, and that's how some not very good CAE analysts, finite element analysts, use software to present the result of their calculation in reports. But why those elements are not look the same as an averaged result in the ANSYS, and can we obtain the unaveraged result in the Siemens FEMA? Yep, we can. So let's came here, and we can see that this option have the moment which called not averaging, and it's clear. So for this moment, we create an averaging of result. So let's do not averaging, and we see not averaging result. And as you can see, now we have those gradients, we have different steps, waves in those result like we see it in ANSYS. And it's very interesting that we now use the mean value, the max value, and it doesn't change anything, and even averaging doesn't do anything. Why? Because we say not average the result. So, and when we came here and do the same, we obtain the same picture, and as you can see on the linear element, we have the one element, one color, so it's one value of the stress. And for quadratic tetra for second order, we have the good linear distribution between different elements. And we can see that sum of nodes inside of element doesn't have a normal result. So that's why they have those strange picture. So this is not about the Siemens FEAMAP in general. That's not about the ANSYS in general. That's about the options of visualizations. Not about every options of visualization, because it's much more, but about in general. And we need the additional one video from the list. It's how to obtain something like, not maybe that, but additional options with the ANSYS FEArytales, with the ANSYS Classic. So see you in the next video.